Hey everybody, let's finish up the video for today working on difference of squares. My sheet will probably look a little bit different than yours right now because I had to space down with the writing up on the top. But what are the perfect square numbers? This is where Miss Idstein has us starting for today. So a perfect square number, just as a reminder, is anything that squares. So 1 times 1 is 1. Oops, I typed the wrong button. 1 times 1 is 1. That makes 1 a perfect square number. We can also have 2 squared. Well, 2 times 2 equals 4, so 4 is a perfect square number. We can do that for any number. 3 squared, 3 times 3 equals 9, so 9 is a perfect square number. So if you're not familiar with your perfect square numbers, that's something that might help you with this video. So 9 is 1, and then we have 4 times 4, which is 16, 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 11 times 11, 12 times 12, and you can just keep going on and on and on. Obviously, this is a never-ending list. You could keep going. I'll put some little dots there to show that you can keep going. But if you are familiar with at least those 12, that'll help you guys out a lot with these kind of problems. Okay, so let's look at this one. Factor the following completely. So there's two different ways to do this one, and I'll show it both ways, and then you guys can decide from there which way you want to go. So when I look at this, I can see that A is a perfect square number. A equals 1. And I can also see that C is a perfect square number. C equals negative 25, although we're going to ignore the negative for right now because obviously no perfect square number is negative. And then I notice it's very important that B is 0. If B is not 0, this particular technique will not work. So I have a perfect square number here, a perfect square number here. All right, and let's see how we're going to factor that. So A times C, 1 times negative 25 is negative 25. So I want two numbers that will multiply together to be negative 25 and add together to be 0. Well, I can use the fact that 25 is a perfect square number because in order for my two numbers to add to be 0, they have to be opposites of one another. So the two things that multiply to be 25 are 5 and 5, but 5 and 5 add together to be 10, and I need them to add together to be 0. So I'm going to go back and make one of those negative. So now positive 5 times negative 5 is negative 25, and positive 5 plus negative 5 is 0. If you guys remember when we did these in class, we put a 0 in there, so I'll do that on this next line so everybody can see it. We rewrote this as x squared plus 0x minus 25. All right, and then we're going to basically do exactly like what we did before. We're going to replace this 0 in the middle with the two numbers that we have right here. So I have x squared, not changing the first one, plus 5x minus 5x. Okay, so the positive 5 and negative 5 are coming from right here. The x is coming for the fact that the exponent on this one is always half of this one. So half of 2 is 1. This is going to be x to the first minus 25. All right, and then we'll do the GCF of both sides like we did before. So x squared and 5x, what they have in common is x. Remember, we always pick the smallest exponent, x to the first there. And if I divide away an x from both of these, 2 minus 1 is 1. And then 5x, if I factor out that x, I have left a 5. All right, now this one, I notice I have negative, negative. I need positive, positive, so they'll match. So I'll factor out a negative 5. And then what I have left in parentheses is x plus 5, because negative 25 divided by negative 5 is positive 5. All right, well, now I have exactly what I want. What's in the parentheses matches, so I'll put that here, x plus 5. And what's outside the parentheses, x minus 5, goes in this other one, x minus 5. I have linear and linear. That's what I'm hoping for, so I have completed this problem. Okay, now look, if you notice that what's in the parentheses is exactly the same with the exception of the fact that the sign in the middle is different. And remember, we said that that was a pattern that you could use on every one of these. So if I skip down here to number 4, Again, I see that my GCF, I don't have a GCF. I see that my leading coefficient is 1, which is a perfect square number. Right here, I have an 81, ignoring the negative for right now. 81 is a perfect square number. 9 times 9 is 81. So if I want to skip this part and use the pattern that I see here to jump straight down here, I have x minus 9 and also x plus 9. Okay, and you can see I put these in the opposite order that I put these, but that doesn't matter. Commutative property says it doesn't matter which order you put them in. So some of you guys said this idea of just following the pattern was very confusing for you. Some of you said this idea of following the pattern was much easier for you. So you pick what's best for you. If it's best for you to keep this 0x as b in the middle and just use the same pattern every time, for some people that's much more comfortable, please do that. If you don't like to do all of that because you can see the pattern, that's okay too. Either way, you're going to end up with this. Okay, let's move over here to number 2. Well, you'll automatically notice a difference with number 2. I can see that instead of a minus in the middle, I have a plus in the middle. And if you guys remember on your little yellow papers when we did this to begin with, I had you write down that the sum of squares, which is what we have here, we have 1 and 25, both of which are perfect square numbers, and they're added together, which gives me a sum. The sum of squares does not factor in the reals. So we'll say that this one is prime. There's nothing we can do to factor this one in the reals, so we're done. All right, let's skip over here to number 3. To start with, on number 3, this one looks like it's not a difference of squares problem. 2 is not a perfect square number. 200 is not a perfect square number either. But I have to think back to what we did in the last video. First step always is GCF. 2 and 200 both divisible by 2, so I'll factor that out. And then what I have left in the parentheses when I divide, 2 divided by 2 is 1, x squared. 200 divided by 2 is 100. And I'm left with that. Okay, so you have two choices at this point. You can either choose, to rewrite. So I would put 2. I'm going to leave that first one just like it is. Just make it x squared plus 0x in the middle minus, might need to scoot over here a little bit. I don't think I have enough space. Minus 100. And then I'm going to do a times c. And I notice that a is 1, c is negative 100. So when I multiply those together, I'm going to get negative 100. And I'm going to use the fact that 100 is a perfect square number. I need my numbers to be opposite one another. So my two numbers that multiply together to be negative 100 and add together to be 0 are going to be positive 10 and negative 10. So I'll put my x squared, and then I'll change to be plus 10x minus 10x using the positive and the negative, keeping that same variable of x. Remember, the exponent is always half of this one. Half of 2 is 1. Minus 100. Oops. All right, and then if I want to factor out from there, remember that 2 that's in the front just stays out there. That doesn't have anything to do with what's in the parentheses. So the GCF of these first two, remember we're just pretending there's a line right there. The GCF of those two is x. What we have left when we factor out that x is x plus 10. And then these two, again, I see minus and minus. I need to see plus and plus to match. So I'm going to factor out a negative 10. And then in parentheses, I will have positive x, because negative 10 divided by negative 10 is positive 1, plus, because negative 100 divided by negative 10 is positive 10. Now, I have the same thing in the parentheses on both of those. So I'm going to leave the 2 that's on the outside. And in that first parentheses, I'm going to put what they have in common, which is x plus 10. And in the second parentheses, I'll put what was outside of each of those, which is x minus 10. And so that is my final answer. We said in the last video, I'm looking to get linear and linear, and that's what I have. So that's good. That's what I'm looking for. All right, we already did number 4. Let's look at number 5. On number 5, okay, again, 3 is not a perfect square number, nor is 27, but I noticed that those have a GCF of 3. So I'm going to factor out the 3. And then what I will have left in the parentheses, dividing each of those by 3, is x squared minus 9. All right, the a here is 1. That's a perfect square number. C, I'm going to ignore the negative. I'm going to focus right here on the 9. Well, 9 is a perfect square number. And remember, we set up here that b has to be 0. Well, in the middle, I don't see an x, so that must be 0x in the middle. So it meets all the qualifications that I need for it to be a perfect square for it to be a difference of squares. So I'm going to do this one with the pattern. I'm going to leave the 3 that's out there. I'm going to put an x and a 3 in both of the parentheses. And then I just need to put in opposite signs. It doesn't matter whether I choose to put the minus first or whether I choose to put the plus first, as long as they're opposite, it's fine. So you can do it again. You can do it with this process, putting in that 0x in the middle, or you can use this process with the pattern. Either way is good. Either way gets you the right answer, and they're both mathematically correct. All right, for this last one, let's see what you guys can do with that one. Can you guys factor out a GCF? Well, no, this one doesn't have a GCF, so we can skip that step. Is this a difference of squares problem? Are A and C both perfect square numbers? 1 and 16, 1 times 1, 4 times 4, so far good. Is B 0? Yes, it is. There's no 0x in the middle there. So we can either factor this one using the 0x idea in the middle. Oops. Or we can go straight to the pattern. Either way, you're going to end up with the same answer, x minus 4 and x plus 4, in whatever order you happen to have. Both of those are good. Okay, let's look down here at number 7. All right, this one looks a little bit tricky because my exponent has changed. But what's your first step always? Well, your first step is to find that GCF, which in this case is going to be x. And if I factor out an x, what I will have left in the parentheses is x squared, right? Because I have to subtract. 3 minus 1 is 2 minus 1. Oops, forgot to take it out of the exponent. Because x, take out an x, there's no x left. 1 minus 1 is 0, so I have this. Okay, so in this case, a is equal to 1. That's a perfect square number. C is equal to negative 1. I'm going to ignore the negative part, just focus on the 1. Again, that's a perfect square number. So I can either do the pattern or I can do all the steps. I'm going to choose to do the pattern because my video is running out of time. That x that's on the front has to stay there. And then what I have in the parentheses in either order is x plus 1 and x minus 1. Again, either order is fine. It doesn't matter which one you end up with because I can see that I have that 0x in the center. All right, this one, first, always check for a GCF. Does this one have a GCF? Yep, has a GCF of 5. So let's factor that out. And in the parentheses, I'll have x to the second. 125 divided by 5 is 25. Okay, so now let's check and see if this one is a difference of squares. A is 1. 1 is a perfect square number, so far good. C is negative 25, ignoring the negative, focusing on the 25. 25 is a perfect square number, 5 times 5. And B equals 0. Okay, so this one is good. This one is possible to rewrite. So if you want to rewrite, you'll put 5x squared plus 0x minus 25. And then when we factor from there, 5 times x minus 5, x plus 5. All right, on this last one, look for a GCF. Well, they don't have a number that's in common. Understood 1 right here, 64. The only thing that goes into both of those is 1. But they do have a variable in common, which is x. Remember, I picked the smallest exponent, x to the first. And when I factor that out, I'm going to have in the parentheses x